right? Is there any competitors?
Google, I kind of
TPU.
ignored them.
Yeah. What's the
I was
story
like,
with
huh?
Google has invented many things, including the AI technology that powers ChatGPT. But right now, the search giant is facing an existential threat that could leave it behind in the AI revolution it started. But before we reveal how exactly Google is running out of time, give our channel a sub to stay up to date with the latest technological news. Algorithm advantage. Back in 2017, Google's researchers literally wrote on the paper, "Attention is all you need."
25 zeros. That is longer, way longer than the age of the universe. It wasn't just a theoretical capability.
This is the foundational technology behind every major large language model that is dominating headlines today. They invented transformers, created the track, and by now, Google should be winning the race, right? This is especially true because now, even Apple has decided to integrate Gemini with Siri, realizing how far behind they are in technology. But there's a level to the game. The brutal reality is that AI leadership doesn't come from algorithms anymore. It comes from silicon. The company with the best chips, the most chips, and the fastest access to cutting-edge manufacturing is the one that will win. Google designs custom tensor processing units, or something we call TPUs. These are chips that are optimized for AI workload and can theoretically give them an edge over their competitors using NVIDIA's GPU. But designing chips and manufacturing them are completely different challenges. Google can draw blueprints all day, but without complete fabrication capacity, those designs are basically useless.
On 1,100 acres in the middle of the Arizona desert, only one set of buildings rises above the horizon as far as the eye can see.
We started construction well before the CHIPS Act came along, and that's in April of 21.
This recently completed 3.5 million square foot building is Taiwan Semiconductor manufacturing.
To make things worse, here's the reality. A company called Taiwan Semiconductor Manufacturing Company makes each Google TPU. If you don't know the reality, TSMC controls 92.5% of advanced chip manufacturing around the world. Yes, we're talking Apple, Google, NVIDIA, AMD, etc. Every single big company is competing for the same company, TSMC, to give them chips. But here's the reality. The company can only produce a limited amount of chips because everyone has a bottleneck one way or another. The main issue comes in when we talk about the geopolitical dimension, because that is something that makes this chip war even more terrifying. TSMC's advanced factories exist exclusively in Taiwan, an island that China has threatened to reunify by force so many times. So, if conflict erupts in the Taiwan Strait, Google's entire chip supply would evaporate overnight. NVIDIA's dominance. While Google is mostly struggling with the TSMC dependency, NVIDIA has built a position that is hard to beat. Even companies like Apple are struggling with it. Their H100 and H200 GPUs have become the de facto standard for training large language models. And if we include their Blackwell architecture, it promises even more dominance in the future. NVIDIA's real dominance is not about its chip, but it's about CUDA. CUDA is the software ecosystem that has been refined over 15 years, where every AI researcher on Earth has been trained to use. Switching from NVIDIA to other chips means rewriting code bases, returning engineers, and even accepting performance degradation over time. In reality, Google's TPU theoretically offers better performance per watt for specific workloads. However, they don't exist in CUDA and reside in a much smaller ecosystem. Outside Google, almost nobody uses TPUs. This means not only do they get much smaller appreciation, but the community support is very limited. There are less optimized libraries, while the company is constantly battling developers that TPUs are worth the switching cost. What exactly ended up happening? Well, NVIDIA's market cap is around $4.68 trillion, which speaks volumes. That's more than most countries' GDP. Google's parent, the Alphabet company, is around $4.08 trillion, which is still a lot, but less compared to NVIDIA as a giant. Google's main value comes from its advertising, not AI hardware. But NVIDIA is eating Google's lunch in one main market, which is AI infrastructure, and Google will need to submit for the next decade if it's not careful. The bottleneck. Moving back to TSMC, it isn't just manufacturing chips, but it is the only company that can manufacture the most advanced AI chips at scale. Samsung makes 5 nanometers chips, holding about 7.5% of the world's advanced market, but TSMC owns the remaining 92.5%. There is literally no plan C.
Key role in China's push for chip self-sufficiency, but faces significant geopolitical challenges.
The node measurement matters. In enormous 3 nanometers chip packs, more transistors than 5 nanometers chips are delivering better performance and efficiency for AI workloads, processing massive datasets across thousands of chips. That efficiency is huge, and it compounds to a whole other level. Being stuck at 5 nanometers when competitors have 3 nanometers means they are burning more electricity, needing more cooling, and processing less data per power. Google currently uses TSMC's 5 nanometers process for the processor for the latest TPUs, which is competitive with NVIDIA's current generation, but NVIDIA has already announced the next generation with their next-gen products. Google's TPU roadmap requires space, which means competing with Apple, NVIDIA, AMD, and Qualcomm for TSMC's limited 3 nanometers and eventually 2 nanometers capacity, ASML controlling everything.
Behind this highly secured door in an ASML cleanroom, there's a giant $400 million machine.
Now we are moving towards a giant that everyone ignores. Think of TSMC as the kingmaker. That's where ASML, the Dutch company, is the kingmaker's kingmaker. This company makes the extreme ultraviolet lithography machines that enable factories to manufacture chips below 7 nanometers. These machines are rarer than chips themselves, and ASML holds 100% global market share because nobody else can build machines like these. Each EUV machine costs between $150 to $200 million, is weighted over a whopping 180 tons, and requires 250 suppliers globally to manufacture this behemoth of a machine. Then there are the mirrors inside the machine, which are the flattest objects ever created. If scaled to Germany's size, the highest peak would be less than a millimeter tall. Building one of these machines requires over a year. Currently, ASML can produce only 50 to 60 annually. That's a whole other level of bottleneck, even for the TSMC. This creates a bigger barrier for companies like Google to produce their own manufacturing facility, because every single tech is being limited to a level where even money cannot fix it. You can't make 5 nanometers chips without the EUV machines, and you cannot buy these machines except from ASML.
Consists out of like 100 different layers. Most of the layers are actually made with deep UV, which is a much smaller system.
But AML is subject to export controls from the Netherlands, Germany, and the United States, preventing direct sales to China. Google's chip strategy also depends entirely on ASML, continuing to supply TSMC with enough machines to meet demand from all customers. In other words, if ASML faces some kind of production issue of geopolitics disruption, there goes Google's advantage, leverage, and without alternatives, they are as good as dead. The dependency chain goes from the USA all the way to Germany. Any break in the chain means Google's entire AI strategy will collapse. But that could be said the same for China too, right? Absolutely not. But before we reveal China's unique advantage, if you're enjoying the video so far, do give us a sub, because we're about to reveal something shocking: China's shadow competition. Did you know the US banned ASML from selling the EUV machines in 2019? That's where China was supposed to fall hopelessly behind the AI rate, but the exact opposite ended up happening. China's SMIC company had managed to produce 7 nanometers chips, even if it didn't have the famous EUV machines. This is an achievement even Western experts thought was nearly impossible. They're doing a technology called DUV, with extreme multi-patterning, which means brute forcing the advanced chips with less advanced tools. Efficiency is China's biggest ally, and they're cashing it to the absolute max.
In October 2025, China's top chipmaker, SMIC, Semiconductor Manufacturing International Corp., hit a market capitalization of roughly $92 billion.
But there's more. China launched the Shanghai Microelectronics Equipment, SME, with the sole goal of building domestic EUV machines. Most people assume this will fail in the coming year or take decades to settle down. But China already has a track record of producing things we all thought wouldn't be possible. If China builds even moderately competitive lithography machines by the coming decade, the entire global semiconductor supply chain would reorganize overnight. This is where TSMC's own stronghold would weaken, to the point where things would drastically change. The Chinese companies would get advanced manufacturing without Western approval. Google would face new competitors with government backing, and chip companies that wouldn't need to negotiate with TSMC for capacity. The main danger that Google faces now isn't just China building its own chips, but it's the Chinese AI companies with guaranteed domestic semiconductor production that are outcompeting Google in the international market, while Google is still dependent on TSMC capacity that might evaporate tomorrow if Taiwan becomes a conflict zone. The competition. While Google is still struggling with TSMC dependency, other tech giants are already making moves to make Google's entire strategy obsolete. Amazon's Graviton processors and Trainium AI chips are one of Google's biggest competitors because Amazon controls the largest cloud infrastructure using AWS. This gives them direct customer access.
AWS Graviton 4 is the latest, most powerful, and energy-efficient processor we've ever designed for a broad range of workloads run.
If Amazon's custom chip becomes competitive with the TPUs on a spec-to-spec ratio, customers will always choose the option that is integrated with AWS rather than dealing with Google's smaller cloud ecosystem. Let's not forget about Meta, which is going all in with the open-source AI models while building a huge internal computer infrastructure. Meta is not selling AI services like Google. They're using AI to improve advertising and engagement, something Google initially planned for. This allows Meta to optimize chips specifically for their workloads without having to worry about external customers. It could also give them better performance per dollar compared to Google's general-purpose TPUs. Microsoft has partnered with NVIDIA, giving them full access to the H100 and Blackwell chips that Google is not even close to. Microsoft has also invested in custom silicon, including the Maya AI chip for Azure. So, between NVIDIA access and custom chips, Microsoft is building the redundancy that Google always lacked. Then we have Apple, who controls the entire stack from chip design to manufacturing allocation at TSMC. Being TSMC's largest customer, Apple gets priority for cutting-edge processes. If TSMC's 3 nanometers capacity is limited, Apple would still get its chips, while Google would wait. Google's strategy. Right now, Google understands that they are in trouble, and this is why they are desperately trying to reduce the TSMC dependency. However, their options are limited. Intel's foundry services are the most obvious alternative because they are investing $100 billion plus to build an advanced fabrication in the US and Europe, positioning themselves as a TSMC competitor or alternative. This is because they're worried about TSMC's capabilities and the geopolitical risk. But for now, no one can be as good as TSMC in making chips. Intel's 18A process, which is equivalent to TSMC's 2 nanometers, isn't even production, ready till late 2025, and Intel has a history of delayed product deliveries. If Intel succeeds, its capacity will be limited and expensive compared to TSMC's high-volume manufacturing. For Google, Samsung is another alternative, but they have already had a yield problem with advanced nodes, which makes them risky for creating advanced chips. Google could split orders between TSMC and Samsung to reduce dependency, but that increases complexity and even forces them to maintain 2 separate chip designs. The perfect option here would be for Google to build its own fabs, but this is essentially a non-starter. Building a single advanced competitor semiconductor fab can cost around $15 to $20 billion and even take 3 to 5 years before producing a single chip. By that time, other companies would be so far ahead of Google that they wouldn't even be able to compete. This would cost hundreds of billions of dollars to them over decades. Drop a comment whether you think Google can escape this dependency trap or if they're destined to fall behind the integrated competitors. Subscribe to the channel if you want to stay up to date, because the next big chip war is already here.